Hey everyone, welcome to this full paper walkthrough for ENGAA 2023 Section 1b. 20 questions, approximately 35 minutes to get through them, so let's go straight into it. Question 21 is a straightforward maths question. You're told that x squared minus x minus 6 is a factor of the cubic, and to obtain the cubic, you must multiply this quadratic by a linear function, x plus c. You can work out the value of c using inspection, and c comes out to be minus 8. You can then multiply x minus 8 by x squared minus x minus 6 to give you the original cubic, and the values of a and b are minus 9 and 48, and they sum to give 39, which is h. Question 22 is a stationary wave question. You're told that the first pipe is closed at one end and open at the other, and that the lowest frequency of stationary wave sound is formed, which means that the highest wavelength of sound is formed. So the length of the pipe is equal to lambda over 4. The second pipe is open at both ends, which means there are antinodes at either end, and the length of the pipe is lambda over 2. For the same velocity in both pipes, because the air is at the same temperature and pressure, because the first pipe has double the wavelength, it must have half the frequency of the second pipe. So the frequency of sound in the second pipe is 8000 Hz, which is D. Question 23 is a maths question on arithmetic progressions, and to solve this question you basically need to know the equation for sums of arithmetic series off by heart. So the sum of an arithmetic series is n over 2 times 2a plus n minus 1 times d, where n is the number of terms, a is the first term, and d is the common difference. So you can write down expressions for the sums of the first 9 terms, 10 terms, and 11 terms, and then use the relationship that the sum of the first 9 plus the sum of the first 10 is equal to the sum of the first 11 to obtain that a is equal to minus 13 over 4d, which is a. Question 24 is a projectile motion question where you're asked to work out the magnitude of impulse that acts on the ball between leaving the cannon and reaching the ground. Now, because it's projectile motion, the horizontal motion and vertical motion are independent of each other, and there is no air resistance, it's assumed as negligible, so the horizontal speed remains the same, which means there's no horizontal impulse. Vertically, you can use the equation v squared equals u squared plus 2as to work out that the vertical speed of the ball just before it hits the ground is 30 meters per second, and the impulse vertically is mass times the change in velocity, which is 2.6 times 30, which comes out to 78 Newton seconds, which is d. For question 25, you basically need to know about the properties of geometric progressions. So for any geometric sequence, the Cohen ratio is the same. So p minus 3 over 2p is equal to p minus 7 over p minus 3. You can then manipulate this to obtain a quadratic in terms of p, and p is either equal to 9 or minus 1. You're told that the progression is convergent, which means that the modulus of the Cohen ratio must be less than 1. And for this to happen, p must be equal to 9. Now the sum to infinity is a over 1 minus r, which is where a is the first term and r is the Cohen ratio, which comes out to 18 over 1 minus a third, which is 27. For question 26, you're told that the child on the sledge is traveling at a constant speed, so the child's kinetic energy remains the same. This means the rate at which thermal energy is being produced is equal to the rate at which the child is losing height, which is mgh dot. Now mgh dot is equal to 60 times 10 times 15 sine 30. 15 sine 30 is the rate at which the child is losing height because you're multiplying the 15 meters per second by sine 30 to obtain the vertical component. And this comes out to a rate of energy loss of 4500 watts, which is C. So question 27 is actually quite a difficult question. The way you want to work out angle x is by using two different circle theorems. The first is that the angle in a semicircle is 90 degrees, and the second is that angles subtended from the same arc are equal. You can use the second theorem to split the 55-degree angle into 40 degrees, which is the same as the other 40 degrees because they're both subtended from the same arc, and a 15-degree angle. You can add this 15-degree angle to the 90-degree angle from the semicircle to get 105 degrees, and angle x is 180 minus 105, which is 75 degrees. For question 28, you're told that all 4 resistors are identical, and if resistor Q dissipates 4 watts of power, then resistor R must also dissipate 4 watts of power because they both have the same amount of current passing through them. This current passing through either resistor Q or resistor R can be written as I over 2. So the current passing through resistor P and resistor S is equal to I. Now the power dissipated is equal to I squared R. So if P and S have double the current compared to Q and R, they must have 4 times the power dissipated, which is 16 watts. The total power supplied by the battery must be equal to the total power dissipated by the resistors, which is 16 plus 16 from P and S plus 4 from Q and R, which is 40 watts in total. Question 29 is a completing the square question. There's no secret trick to these. The best way to get quick and accurate at doing them is to do as many complete the square questions as possible. So when you complete the square on f of x, you end up with root 2 times x minus 3 root 2 over 2 all squared minus 9 root 2 over 2 plus 4. And when you take the values of p, r, and q, you get the value of p times r minus q as 4 root 2 minus 6, which is f. Question 30 is quite a difficult question. It's quite similar to the types of ladder problems you get in A-level mechanics. And the way you want to go about solving it is first by writing down all the vertical and horizontal forces acting on the planks. You can focus on only one plank because the forces on both planks are identical. And then you want to take moments to obtain the value of the frictional force. So the vertical forces are the weight of the plank and the normal reaction force from the ground. And the horizontal forces are the reaction from the other plank and the frictional force. Now you can quite easily see that for the planks to remain in equilibrium, the frictional force is equal to the horizontal reaction force from the other plank. So you can take moments about point P, where the plank is in contact with the ground, to obtain an expression for the reaction force R in terms of mg. Now when you go through the calculation, R comes out to be mg over 2 root 3. And m is 40 kg from the question. So the magnitude of the frictional force at P is 200 over root 3 newtons, which is B. For question 31, you can just work through the integration. So you add 1 to the power divided by the new power to get x cubed over 3 times 3 minus root 5. And then plug in the limits 3 minus root 5 and minus 3 minus root 5. Once you go through the calculation, you end up with your answer as 28 minus 12 root 5 over 3, which is E. So question 32 takes a while to wrap your head around, but the best way to go about solving it is to consider force equations for each of the 3 blocks P, Q, and R individually, using Newton's second law, F is equal to ma, and then solve them simultaneously to work out the reaction between Q and R. So first looking at P, you have 20 newtons minus the reaction from Q on P minus the frictional force of 2 is equal to 4 times the acceleration. Looking at Q, you have the reaction from P on Q minus the reaction from R on Q acting the other way minus the frictional force of 1 is 2 times the acceleration. And look at block R, you have the reaction from Q on R acting to the right minus the frictional force of 1 acting to the left is equal to 2 times the acceleration. You then solve these simultaneously to obtain the acceleration as 2 meters per second squared and the reaction between Q and R as 5 newtons, which is B. For question 33, you're given a function f of x equals a over x plus b over x squared, and you're told the values for f dash of 1 and f double dash of minus 1. So what you want to do is work out f dash of x, which is minus a over x squared minus 2b over x cubed, and f double dash of x, which is equal to 2a over x cubed plus 6b over x to the 4, and then plug in the values 1 and minus 1 to get 2 simultaneous equations in terms of a and b. You can then solve these equations to work out the value of a plus b, which is minus 7 over 5. So for question 34, you have an object released from rest at height big H above the ground, and it's falling in a uniform gravitational field. At time t after being released, it's fallen a distance s and is at a new height little h above the ground, traveling at speed v. Now, looking at the 3 rows in the table, it can't be row 1 because using the Suvat equation, you can derive an equation for h in terms of t, with h being 0 minus 5t squared, using s is equal to ut plus half at squared. Looking at the second row, the kinetic energy is half mv squared, and kinetic energy gained by the ball comes from the GPE lost by the ball, which is mg times h minus h. So the second row does work. Looking at the third row, the GPE of the ball is mgh, which is equal to mg times big H minus s. So the third row works as well. So for the graph, the first row doesn't work, but the second and third rows do work. So the answer is G. For question 35, you want to start off by writing 2 as log 39. And using log rules, you end up with x squared plus 3x plus 2 is equal to 9 times x squared plus 2x. You can then manipulate this further to get 8x squared plus 15x minus 2 equals 0. And you can solve the quadratic to obtain two values of x as an eighth and minus 2. The real value of x that satisfies the equation is an eighth, because if you plug in x is equal to minus 2, you end up taking the log of 0, which is impossible, so the answer is A. For question 36, you have a cylindrical conductor in series with a 20 ohm resistor. The voltage of the battery is 20 volts and the current in the circuit is 0.2 amps. The conductor is then removed and reformed into a new cylinder with 4 times the length. If the new cylinder has 4 times the length, in order to keep the volume of the same, it must have a quarter of the area. Resistance is equal to resistivity times length over area. So if it has 4 times the length and a quarter of the area for the same resistivity, the new cylinder has 16 times the resistance. The resistance of the old cylinder was the total resistance of the circuit, 20 over 0.2, minus the resistance of the resistor, so it was 80 ohms. And if you multiply that by 16, you end up with 1280 ohms, which is E. For question 37, you get the constant term when x is raised to the power of 4 for both 2 over x and x to the 4. And the value of the constant term is 8c4 times 2 over x to the power of 4 times x over 4 to the power of 4. The value of 8c4 is 8 factorial over 4 factorial times 4 factorial. And with a bit of manipulation and cancelling out, you end up with the value of the constant term as 210 over 48, which simplifies to 35 over 8. For question 38, you're told that there's a phase difference of pi between the incident and reflected wave at Q, and that waves that reach R via the reflector are in phase with waves that reach R directly from P. For the greatest wavelength, the path difference between P and R via Q must be lambda over 2. The path difference being lambda over 2 would give an additional phase difference of pi, and this would add to the existing phase difference of pi from the reflection to give a total phase difference of 2 pi, meaning the waves that reach R would be in phase. Now the distance PR is equal to D, and the distance PQR is equal to 2D over root 3. So lambda over 2 is equal to 2d over root 3 minus d, which means that lambda is equal to 2d times 2 over root 3 minus 1, which is A. So question 39 requires a bit of thinking. You start off with x squared plus y squared equals 1. And for the greatest possible value, you want y to be equal to the positive square root of 1 minus x squared. You can then set a variable d equal to 2x plus 3y. And subbing in y from the previous equation, you get d is equal to 2x plus 3 root 1 minus x squared. You want to find the maximum value of d as x varies, so you take the derivative and set that equal to 0. When you go through the calculations, you end up with x is equal to 2 over root 13, and y is the positive square root of 1 minus x squared, so y is equal to 3 over root 13. This means that 2x plus 3y equals 13 over root 13, which is equal to root 13, which is G. For question 40, you work out the total spring constant the same way you'd work out the resistance of two resistors in parallel. So one spring constant times the other over the sum of both, which gives you a total spring constant of 150 newtons per meter. The total strain energy is then just using the equation half kx squared, so half times 150 times 0.8 squared, which gives you 48 joules, which is A. Thank you for watching, everyone. Hope you found it useful. And for more ESAT practice and preparation resources, make sure to check out our website. Link will be in the description.